Okay, well, our next panel is getting settled up here. Our moderator will introduce the panel. I'd like to introduce our moderator, Professor David Mendel. He's a professor of aeroastro, so he certainly has his technology credentials, but what I really, really appreciate about David is that he is also a professor of the history of technology and has done some very, very interesting work here at MIT on things like the future of work. He's also an expert in robotics. He's written a very interesting book called Our Robots Ourselves. And so I think he's very, very well suited to guide us through this next discussion on connectivity. So David, the floor is yours.
Thank you, John, and thanks to Jehan and Annie. As they know, I actually teach a course on entrepreneurship in aerospace and mobility, and it meets on Wednesday mornings from 9 to 12. So when they asked me to do this, I said, sure, I'd be happy to, but can I bring my 9 students along with me? And they're all here helping out, taking notes. It's great to see all the folks from the class. And so thank you all for helping me teach this morning. It's much more educational than sitting alone in a room with me for 3 hours for all the students to be here, and there's so much to absorb. I think this topic is a particularly important topic. I've spent a lot of years, including with John Leonard in the undersea world, thinking about autonomy and what autonomy really means. And going back to the 80s and 90s when we began playing around with autonomous vehicles in the deep ocean, it always meant, almost by definition, freedom from infrastructure. And autonomy and infrastructure were literally at odds with each other, or it was a paradox to say you have autonomy that interacts with infrastructure. And I think actually a lot of the autonomous vehicles in the automotive space started out thinking that way as well. I remember once at an early visit to a certain large West Coast driverless car group, maybe in 2015, and the engineer said, look, the vehicle doesn't use any infrastructure, it just follows the lines on the road. And of course, in the world that I live in, the roads, the lines on the roads, almost anything in the human-built world can be considered infrastructure. The world's come a long way in the last 7 or 8 years, and I think most folks would feel that the nature of autonomy in almost any domain, I work a lot in the aviation domain as well, is connected in one way, and that autonomy is a kind of evolving, real-time relationship between the vehicle and the infrastructure, which isn't to say the infrastructure is always there or always on or 100% reliable or secure or any of those things. Actually, my other class this semester is teaching about the Apollo moon program, and the Apollo command module and the lunar module, they were actually only fully autonomous for a very small part of the flight, which was when they were behind the moon. And then they actually could navigate and work with no relationship to infrastructure on Earth. The entire rest of the flight, which was about 2 weeks long, was in constant conversation with people and machines on the ground. And I think that's a pretty good paradigm for autonomy in the world as it's emerging. The subject was also raised earlier around safety and what role can infrastructure play in improving safety. And ultimately, you're in a world of questions about, systems questions about sensors and computation. There's a saying that a cheap sensor in the right place is better than an expensive sensor in the wrong place. So why shouldn't a car be able to approach an intersection and effectively download or upload, depending on how you think of it, all the latest goings-on from what's happening in that intersection? And then you're, of course, into questions about latency, bandwidth, security, and resilience around networks. And these are all questions that are really almost the flip side, but the mirror image of autonomy in all these cases. And so it's really great to have a panel, and I expect to learn a lot from our panelists who are in that business. I myself started a company that does precision navigation systems in urban canyons, underground, indoors, to sort of offload the navigation from the vehicle into the infrastructure in ways we have done successfully with GPS, but it doesn't work everywhere. So the panelists today are João Barros, founder and CEO of Veniam, which we'll shortly hear a great deal about. Dennis Ong, who leads 5G and V2X efforts for Verizon. Raj Paul on the screen here, leading mobility for Microsoft. And John Quant, Global Director of Mobility and Advanced Technologies for Ford. So maybe I'll start with João, both because you're first on the list and standing here. And tell us a little bit about Veniam. It seems like you guys just get this idea from day one.
Well, thank you so much. It's a true pleasure to be back at MIT. So I was a visiting professor at Leeds between 2008 and 2011, and it was some of the best times of my life for me and my family. So it's really wonderful to be here. And yes, I have been toying with wireless networks of moving things for about 20 years now. And it really is very different when you're doing the research in the lab and doing prototypes and trying, and then actually building a business around it. And so we started together with my co-founders, so Robin Chase of Zipcar, Roy Russell, and also Susanna Sargent, my colleague. We started first by looking at vehicles not just as transportation machines, but as part of the wireless infrastructure, as part of the smart city ecosystem. And so vehicles can be way more than just moving people and things from point A to point B. They can be Wi-Fi hotspots for people and expand internet coverage. They can be mobile sensors and gather massive amounts of urban data to improve people's lives. And so we started developing the networking software that is required to enable vehicles and drones and robots and industrial machines to connect to each other and to the infrastructure in a seamless way and be able to make the decisions of what data do I send through this network, through that network, what data do I send now, what data do I send later. And so we deployed the largest mesh network of connected vehicles in the world, first in Porto, Portugal. Then we built and operate similar networks in Singapore, in New York. And that's when we bumped into the first challenge, which was how to scale that as a business at the time. So 7 years ago, there was no hardware actually that for vehicles and fleet vehicles that actually had the capabilities to run these sophisticated algorithms. So we did the hardware ourselves. But then also realized, oh, most of the fleets don't even have trackers. They don't even have position trackers at the time. So we were really ahead of the curve. Fortunately, then the automotive industry realized it could save about 30% of their warranty costs by getting onboard diagnostics data and doing over-the-air software updates. And so we started working with the auto industry and developed a software development kit with APIs that did connection management, data management, policy management, security management in a seamless way, and really found one use case that was incredibly valuable for the industry. Up until recently, the industry had been looking at Wi-Fi just to connect the smartphone to the car, V2X just for safety, and 4G or 5G for everything else. But we actually proved that we could do better than that. We could use Wi-Fi not just inside of the car, but actually to connect to millions of Wi-Fi hotspots on the move and send 10 times more data at a 60 to 80% lower cost per gigabyte. And then we showed that you could use V2X not just for safety, but actually for vehicles to share data directly with each other, which means, for example, an over-the-air software update. Why should every vehicle be downloading an over-the-air software update through an expensive 4G or 5G link if they're able to do it in a peer-to-peer fashion securely for free? This is great for the operators as well, because actually the operators have lots of network assets, including Wi-Fi networks and so on, that so far are underutilized. And a lot of the IoT data can actually go through all these different network assets. And so Verizon is actually also one of our investors. So the key thing that we've been thinking is how can we make the most out of all the networks that are available and provide that seamless connectivity as if it was just one network, as easy as putting a SIM card and connecting it to the network. And how can we then maximize the utility of the vehicles by using data and networking?
Wonderful. So cool. Dennis, as Zhao mentioned, you guys own probably as much infrastructure as one can imagine. And how is Verizon thinking about V2X and vehicles and security and all the critical components for at least building on networks that are already deployed that we all use every day?
Yeah, and that's a good question. Is it on? Yeah. And yesterday I was at the reception, and people asked me, what's Verizon doing in V2X? So actually, I joined Verizon 4 years ago, and leading V2X. And I think for someone who's familiar with V2X, actually, US has been toiling with V2X DSRC for the last 20 years. And but I don't think it actually scaled. There were pockets of pilots everywhere in the country, but it did not scale because it required installation of like roadside unit, and in different cities you can install them, but it will cost like billions of dollars to deploy everywhere. So from Verizon perspective, we think that we believe that 5G and also edge compute will be able to connect vehicles, autonomous vehicles, with each other, into the infrastructure. Because for Verizon and for other mobile operators, we have the incentive, business incentive, to deploy 5G anyway for multiple purposes. And so we are going to leverage this asset in connecting vehicles so that they're safer, they're more, and even now we're working with like partners like Honda. We actually, for example, upload LiDAR information from the vehicle to the edge compute, because we are deploying edge compute everywhere in the country. Right now, I think we have about 10, and we're going to deploy it a lot more. And so I think it addresses the question about latency and also bandwidth. I think that the questions that people have about 5G, 4G, and it's about latency, about the bandwidth. But as we're moving to 5G, as moving to edge compute, we are trying to address those questions about latency and bandwidth, and more importantly, how to scale, right? We don't want just maybe the V2X to happen on this particular part of the city. We want V2X to be able to scale to cover most of the population, 95%, right? Otherwise, this is not going to be useful. So for us, Verizon cannot do it alone. We're working with many auto OEMs, cities, and different OEMs in trying to make that happen. So I think it's very exciting for me for the last 4 years, and we see a lot of excitement in this area.
Wonderful. Raj, different point of view, I'm sure. How is Microsoft looking at the question of mobility and connectivity?
Mute. Raj, you're on mute.
Can you hear me fine now?
Yes, thank you.
Yes.
Thank you. No, I mean, all of us know the automotive industry is going through a huge transformation. So the way we look at some of this transformation is a lot of the OEMs are trying to become mobility service providers. I mean, tier ones are trying to become tier 0.5s. And from a disruption standpoint, we see a huge cross-industry play happening. I mean, today in our panelists, I had 3 panelists from the insurance industry, for example. Right? Insurance is starting to play a big role. Charge network providers. And similarly, if you look at a lot of the interesting use cases, when a AV gets into a city, the kind of interactions it'll have with the city infrastructure, for example. So I think the automotive industry and the mobility industry at large is going to be a huge cross-industry play. And as a hyperscaler, the Microsoft Cloud, we think will basically help bring the adjacent industries together from a mobility standpoint.
And John, maybe you can share with us Ford's point of view as a mobility provider and vehicle developer.
Sure. And apologies to everyone for not being able to join you in person. When I looked at the list, there are many names that I recognize on the attendee list and wish you well and wish I could be there with you. At Ford, we increasingly see the future of mobility as both increasingly electric, increasingly connected, which is what we're talking about today, and increasingly and ultimately more autonomy than we see today. So many of you have probably heard me talk about this, in the past with some of the things that you brought up earlier. I think with the degree to connectivity and its intersection with autonomy, I've always thought that the way that one way to view connectivity in terms of enabling autonomy is that it is like a fifth sense on that vehicle. If you think of autonomous vehicles today, and the fact that they operate as an independent unit in terms of its computing power and its sensing power, it has radar, it has LiDAR, it has photo, it has telemetry. And with those four things, it does, what we were programming the vehicle to do and sensing its environment and acting, based on historical experiences and everything that's part of that vehicle set. I think with connectivity then, it becomes like a fifth sense and almost like a confirming sense against those other four. So it could be redundant, or it could be the enabler that we've been talking about, especially as you begin to rely on the edge and the network to offload some of that compute need from the AV itself to the cloud. That, of course, requires a threshold level of connectivity between vehicles and environment and infrastructure. And when I get asked the question, when do we see autonomous vehicles being deployed in mass, either in cities or in other applications, I would say that it's likely going to move lockstep with the deployment of a connected infrastructure and connected vehicles to one another and to their environments, whether that's infrastructure or vulnerable road users. So Ford has made a commitment, in this space into all of those three trends that I mentioned: electrification, connectivity, and autonomy. And we're looking forward to working with people here on the panel as well as people in the audience to bring that future to reality. Thanks.
Wonderful. Then, in some ways, a more challenging question, which is, given my startup hat, what's the business model? Not all, but a lot of the things we've just heard about require capital investment. Somebody's got to put the infrastructure up, and therefore they've obviously got to recoup that investment, and somebody's got to pay. And obviously that's somewhat related to who's going to gain value out of the pieces of it, although not always exactly the same thing. So do I have a $100 a month connectivity bill for my car? I'm troubling enough to have one of those for my phone. Or does it come with my maintenance on my car? Or, and I'm sure there's many other more creative ways to think about it. So, Joe, I'm sure this is a problem you've faced, and
yeah, absolutely. When you're venture-backed, you can't afford not to have a business model. So we started by looking at the existing infrastructure and what is the most that we can do with the existing infrastructure, because it was pretty soon clear that it would take a long time for roadside units to be deployed with DSRC and later with V2X. But many telecom operators turned your home Wi-Fi router into a public Wi-Fi hotspot. So you have a private channel for you to use at home and a public channel that is broadcast. And so we tried to figure out how can we connect on the move in less than 2 seconds to these Wi-Fi hotspots, push data, and be able to do that. We were able to solve the technical problem, and we were able then to also build the ecosystem to be able to provide that ability to offload data to the Wi-Fi infrastructure. And it's a software as a service business model, and you pay for what you use. And that's just the entry point, because then the engineers look at the platform and they realize, oh, there's an API for us to do data management. There's an API for us to basically do policy management. For example, the position of a vehicle needs to be sent like every 10 seconds through whatever network is needed, but onboard diagnostics needs to be sent twice a day. And as you split these different data flows, you're able to also build them and charge them separately, so that, for example, the maps company can pay for the maps, Amazon can pay for Alexa, and others can pay for. And that opens up the ecosystem, because right now, whenever somebody wants to roll out a digital application to an automaker, they say, oh, that's going to explode my cellular costs, can't do it. And so that opens up different ways to split those costs and enable new business models. That's the beginning. I really don't have an answer for the V2X side of things, because it seems to me like it's taking so long precisely because the business question has not been answered. And even though everybody pays lip service to how important it is to save people's lives, at the end of the day, they're looking at the bill of materials, the chicken and the egg problem with the infrastructure, and so on. And so I think there's a role for government to play there to be able to accelerate that transition.
Dennis, who does Verizon see as a V2X customer?
Actually, that question keeps me awake. Right? Keeps me awake. And to be honest, I think consumer probably is not the first customer. I don't see consumer. I don't think that they will pay a dime, right, for safety. They expect safety, right? They don't pay extra for safety. And so I think from our perspective, I think that could be customers like Amazon, right? Like robo trucks. And I think they have a ROI for this. If they can deliver faster, 5 minutes faster for one route, I think they're willing to pay. So like robo taxis, robo trucks are the ones that we see are the early adopters. That's the way I envision is that they will have connectivity anyway. They have connectivity to a network, either 4G or 5G. And then we can provide them signal phase information. We can even tune the signal phase so that they can get to their destination maybe 10 minutes earlier. Or maybe when they're on the highway, they can have semi-autonomous. You can have platooning. You can have 3 trucks running. And then you can save energy. And then you can have human driver, truck driver, sleeping on the you have a lead. For example, you have 3 trucks. The first truck, a person will be driving, but then the other 2 trucks, like the truck drivers are sleeping because you cannot drive 24/7. And then in a way, you can also increase the efficiency of trucking. So we see basically the commercial side in trucking, in robo-taxis be our first customers, and they could be the one that pay first. And eventually, they help us to build out the V2X infrastructure. And then we can benefit all the other consumers then.
So if you're using V2X to enable autonomy with these commercial customers, how does then that force you to think about resilience and uptime? And is it 6 nines that's required, or is it a more opportunistic when you're in the network, you can do things that you can't do when you don't have the access?
Yes, I think it's similar to the Apollo question. When we're providing V2X, it doesn't mean that the vehicle doesn't have the LiDAR and the radar and the ADAS, right? They still do. But for most of the time, 95, 96% of the time, they'll be connected to the network and they'll receive valuable information. So, I mean, definitely we can increase the reliability. 5G, we can definitely increase the reliability. And we can also have network slicing. That means that we can slice a network just for transportation. Right now in 4G, every one of us got the same kind of quality of service. When we go to 5G, we can slice the network. We can increase the reliability just for transportation. But for consumer, if they're watching YouTube, I think it's fine if they have a little bit delay. But for transportation, we can increase the reliability to like, well, in the industry called 5 nines or 6 nines, right? Maybe a few minutes of downtime every year. Mm-hmm. So, I mean, we can do that once we can scale, once we find a business case for it.
Raj and John, how are you guys thinking about the business case for how you imagine infrastructure-based comms here?
So David, my perspective on the business model around connectivity is in the late 90s when telematics started. Right? There were business models based on connectivity, which was more a subscription-based model. But if you look at the way connectivity is playing a role today, it's basically expected. That to what David said, to what Dennis said. Safety security is something which people would want to take for granted as part of buying a vehicle. So, and similarly, if you look at some of the transformation we are seeing in the industry is pretty much every OEM or most OEMs want to become a platform provider, right? What I mean by that is they are looking at ways to get into not just new business models, but to also monetize some of their existing assets. So I think connectivity is going to be that underlying thing what the OEM is going to do, basically from a monetization standpoint, which means connectivity will be part and parcel of what they're going to do. And I don't think as a consumer, you're going to see a connectivity cost per se, but on the flip side, you might buy services from OEMs, which you won't mind paying, but that obviously is going to use the connectivity which the vehicle is going to have.
Yeah, I don't have that much more to add here. I think the way that both Raj and others have described this, there's almost like a Maslow's hierarchy here toward the things that I think consumers will expect that'll be baseline. There'll be certain basic safety messages that will be provided. Then I think as you move up, depending on the technology, depending on the use cases and applications, there could be things like tolling and other efficiency measures that you could charge for in a subscription service. So we haven't been very prescriptive about this. I think we have to see, how the infrastructure evolves, how deployments evolve, what competitors do. But I do think that there will be an expectation, at some point that not only will you have just blanket connectivity to do over-the-air updates and all the things that need to be done, but ultimately there will be this basic safety package in there that complements the existing technologies on the vehicle. And we have to see, what use cases we can charge for from there.
So what we're seeing from working with auto OEMs and video telematics is that you can greatly strengthen the business case of V2X technology by looking beyond safety. You still get the safety benefits, but you use it also for a truly distributed edge where you can share data among the moving vehicles, among the vehicles and the infrastructure. And that enables not just safer transportation, but actually a number of applications from cloud-based navigation systems to location-based services and so on that today are hindered by the cost of cellular data. And so there's an interplay here between how much it actually costs to use 4G and 5G, and how much lower that cost would be both for the telco and also for the mobility providers and auto OEMs if the vehicles actually were as distributed as the internet itself in terms of how they share data.
Mm-hmm. Reminds me of, there was a phrase in the 90s that was, the network is the computer. And I increasingly think the city is the computer.
Yeah.
And actually, an interesting question about how that plays out rurally. But you're in a world where there's pieces of computation and sensing and services all around, but not an easy thing to manage and set up. And now we are, as was mentioned, 2 days past the signing, barely 24 hours past the signing of the infrastructure bill, which is a major moment and I think defining for a generation, depending on how it plays out. And of course, connectivity and data is well recognized as part of infrastructure. And Dennis, you had mentioned, I think, the role for government in certain aspects of deployment. And we, of course, know that government was crucial to enabling the telephone network, which, by the way, the first telephone network ever was from about a mile downtown Boston right down Main Street here in Cambridge, when Alexander Graham Bell set that up. What is the role for government, given where we are today? Is it a standardization story? Is it ensuring equity and kind of equal access? Are there other dimensions that, given where we are today, there's an appropriate role for government? Or is it fully market-based and we'll have multiple competing networks with different kinds of access?
Actually, I had a meeting with a major auto OEM last week. That was the question. Because about business case. Because we're talking about safety. And then that auto OEM was very exciting about working with us in terms of piloting V2X. But then he asked me, would this be regulated, like in China? And I said, I don't know. I don't have a crystal ball. And I said, oh, in that case, I don't have a business case then. I think the question is that, safety is difficult to set. You cannot package it, or difficult. And so I think that's where the question is, right? Is that Because right now, for example, like if I want to call someone on an AT&T phone, I can connect, right? Right. If we let the market to play out its journey, it could take many years, right? So I don't have an answer, but I think this question is very important because because the question is that, for example, like vehicles connecting to Verizon or vehicles connecting to AT&T, they have to talk, right? They have to talk, and so can we do that without regulation? Probably, but it may take some time. So would regulation comes in and help? Maybe.
Raj or John, you have thoughts about the role of government?
From a regulation standpoint, DSRC has been tried to be regulated, meaning the government tried to mandate it for quite some time, but we saw the adoption of DSRC. But I think from a safety security standpoint, I think regulations will help, and I think the V2X adoption, I think will probably take a different way, particularly now with the autonomous on the horizon. I think that could be an interesting play now from a V2X standpoint. But on the flip side, I mean, since we have Verizon on this call, I mean, let's take 5G, for example, right? When 2G to 3G migration happened, this was a killer app, right? So now I'm sure carriers are going to look for the next killer app, and autonomous is expected to be the next one of the killer apps to 5G adoption. An interesting thing with CV2X, with OEMs looking at adopting 5G, for example, I mean, from a bandwidth standpoint, I think V2X will start coming into focus now because they're going to adopt the network for other reasons anyway. But I still think the government is going to play a role here. I mean, particularly when you leave cities, for example. I mean, I'm not sure how whether the capability from a 5G standpoint is going to be as good as cities when you go to urban areas and things like that. Which I think the government has got to play a role in.
Of course, government's going to play a role. I don't. That's without question. And I'm not saying that just because Robert Hampshire's on the on Zoom with us here. I wish he was on the panel as well, because I know he has opinions here and has an incredible amount of experience in this space. But they play a role, obviously, in regulating spectrum, which we're all want and need, both presently and in future use cases. They play a role potentially in mandating safety applications. And of course, they play a role in helping with deployments. And if you look at the infrastructure bill that was passed, these might be small numbers relative to the total, but there was additional funds provided to what was previously known as ATC MTD. A lot of you folks are familiar with that. Money's provided through SMART grants, and then also additional programs to fund pilots and conversions and support of both connectivity and AVs. So I think this flywheel is really just getting started at this point in terms of government support, for both infrastructure. And I was encouraged by the president appointing former Mayor Landrieu to the position of almost like infrastructure czar, if you will, to work with all of the other agencies to try and make sure that there's an efficient deployment of these. And I would hope that between our work in the private sector and what the public sector could be empowered to do through a lot of this funding, that we get that flywheel started, people begin to see the benefits of this, and the funding begins to increase to help state and local DOTs actually deploy infrastructure. The things that are onboard units, that's on us. That's not something that public funding necessarily is going to support. But you do want that, in addition to vehicles being connected to one another, you do want that infrastructure component for safety, for efficiency, and all the things that we've been mentioning.
Zhao, you have thoughts about that?
Yeah, I spent about half my career in the public sector and half my career in the private sector, and what I see is really that we need to build bridges between the business aspect and the regulation in a way that benefits people. And what I see with the emergency of climate change is that the urgency to get that together, beyond the aspect, obviously, of saving people's lives in accidents, is just enormous. And there's a tremendous advances on the AI side on how to leverage all sorts of urban data, vehicle data, mobility data to actually lower our emissions. And I would love for the discussion to move also towards that, which is how do we ensure then that the massive amounts of physical data that have to travel to the cloud or be processed at the edge. How do we enable that and make a lot of the discussion about also about the data? There are some companies doing IPOs right now with multi-billion-dollar valuations just on the promise of data marketplaces for automotive data. But there's the need to actually move that data, again, from the vehicles and from the physical world to the cloud. And I think that both from the business perspective and also from the regulatory side, this is an area that is vastly overlooked.
Do you imagine your solution as also a kind of resilience story where when we think about climate events taking down infrastructure, absolutely, if suddenly all the cars can create a temporary internet among each other, that's a form of climate resilience?
Absolutely. We call the company Venium, which is vehicle networking in a mesh, because precisely vehicles have batteries. They will continue to operate even in some, not all, but some catastrophe scenarios, and they can save lives also that way. I think ultimately it's the dream of having a truly distributed, decentralized internet, because it's true that the internet is largely decentralized in the core. It's not at all at the wireless edge. So all our devices connect to an access point or to a cell station. We're very far from having a fully distributed edge. And there's a huge opportunity in doing that also for resilience, as you mentioned.
Wonderful. So we need to wrap up to introduce a couple of folks for the next session online. I'll just say the historian in me sits here and remembers that the history of information technology and the history of moving stuff through the world have always been very tightly coupled. The birth of alphabetic writing started in the ancient Near East and distributed through the Mediterranean by maritime trade. The great historian from Harvard Business School, Alfred Dubont Chandler, has a great saying, which is the railroad and the telegraph marched across the continent in unison. And so we've got the little bits and the big parts and the boxes moving together, and it's really exciting to hear about the next chapter of that story. So thank you all, and look forward to the table conversations.
Wonderful. Thank you very much.
All right. Thank you so much. Thank you so much. So now we revert to the roundtable discussions. So we have a little bit over 30 minutes. So please, same routine. Introduce yourselves to everybody at your table. Reflect on what you just heard, contribute your ideas, and try to identify any gaps in the knowledge area. Thanks so much.